I'm recording. So today what we're going to be doing is trying to do as much of the review for the final as possible. What I'm going to do is I'm going to start out by sharing my browser with you, and we'll go over to our class and I'll show you where I'm getting material from. Okay, so we're in week 16 of our course. Okay, and that's the last week of the course before the final exam. And you can see here's the stuff we did on Lagrange multipliers last time. Okay, so for this week, by Sunday, you need to complete Lagrange multipliers. And again, this final exam practice is not a required piece of the course. This is kind of the best way to study for the final exam. It's kind of a training exam for the final. Okay, and what I did for today was I printed off my version of this final exam practice with my questions and my numbers, and I'll go through those types of problems. Okay, so there should be similar types of problems on the final, but just not with the same numbers. Okay, the only other thing you need to do, and you can do this right now, I mean, not right now, but when class is over, you can go in and check your grade on test and just send me, complete this assignment by just telling me what you think your grade is, what you think you're still missing, and, what you think you need help with. Conversation with me to kind of share information about how you're doing in the course. Okay, again, as I said at the beginning and a few times during the semester, my goal is for everybody in this course to be successful. So it is kind of 11th hour right now. I mean, we are like the week before finals, but share with me what you think you need in this grade check. Okay, here's the final exam. It's due by December 15th, which is next Tuesday at 11:59 p.m. Again, you have one opportunity to take this exam, so please don't open it till you're ready. Make sure you have everything you want to use with you. And yes, you can use any of the materials in the course, any of the calculators online. The only thing you can't use is somebody else's brain. Okay, so please don't ask your brother or a tutor or a friend for help. Okay, just use what resources you have, but anything's fair game. Okay. And if you want me to review your exam and give you partial credit, please upload your work. Okay, so as you're working on the final exam, write stuff down and then either take pictures of it or scan the work in and upload it to this assignment. Okay, that way I can give you partial credit. If you got most of the way through a problem or you had the right idea, just made a mistake with the math. Okay, so anybody questions on any of the final exam stuff? Questions on any of the stuff related to the final? Okay. So again, this practice exam, the idea behind this is everybody can try it or not as you see fit. I strongly recommend that you try it for practice, but I will give everybody the 20 points for this exam. So this practice will not affect your grade at all. Okay. What affects your grade is the final. Okay. And again, what I'm going to do with your final exam grade is I'll go back through the course. All right. And as long as you scored higher on the final than your lowest exam score, I'll make a replacement. Okay. So as long as you do well on the final, it can kind of pull up your lowest exam grade as well. Okay. So one last call. Anybody questions on anything to do with arrangements for the final? Again, whatever you do, please don't miss it. There's very, very little time to make anything up because I need to have my grades in by the end of next week. So I'll take a pause here and see if anybody has questions. Meanwhile, I'll try to share my tablet with you. Okay, now let me try to share that content. Okay, everybody should be seeing final exam practice. And again, this is similar to what you would see when you open that final exam practice. Okay, it doesn't count in your grade in the sense that if you don't do it or you score poorly on it, that won't impact your grade at all. Okay. So before we get moving with the questions, there's 20 questions on here. There's 20 questions on the final. Okay. I just want to go through the types of questions that are on here in case we don't get to do all of them in the next hour and a half. Okay. As Alicia suggested, we're going to start with word problems because those are the ones people struggle with the most. And then if anybody else has requests, put them in the chat and we'll try to do what you want to see rather than going through it chronologically. Okay. So as far as types of questions, we've got systems of equations. Remember, this was the first topic in the course back in August. Okay. You can certainly use the Symbolab equation solver. How do you do it? You put stuff in a matrix and you have Symbolab solve it. Okay, so here's a plain one where all you've got to do is copy the coefficients and right-hand sides and put it in Symbolab. This one, you've got to figure out how to build the matrix first. Okay, same thing with question 3. Question 3 is a mixture problem, but again, you can build the equations from it. Okay, since the request was specifically for the Lagrange word problems, okay, I'd like to start with those. These are also word problems. So what I can do here is I can begin by setting these up as equations, and then if we have time, we'll come back and solve them with Symbolab. Okay, because again, these are quick. So this one with the movie theater, it has a seating capacity of 301. And the theater charges $5 a ticket for kids and $7 for students, 12 for adults. There are half as many adults as kids. And if the total ticket sales were $2,180, how many children, students, and adults attended? The very first thing you need to recognize is how many variables you have here. Okay, so in number 2, how many variables are there? Okay, I'm asking you. Okay.
3.
3. Okay. You've got students, you've got children and adults. So the first thing you want to do is choose your variables. So let X be the number of kids, Y be the number of adults. And again, which ones you pick don't matter as long as you keep track of them. See the number of students. Okay, now I have 3 variables. Okay, that kind of implies if I'm going to solve for numbers like actual numeric values rather than one in terms of another, okay, I need 3 equations. Okay, that's kind of a feature of linear equations. Okay, you need 3 pieces of information to get 3 distinct numbers. The first piece of information I have is seating capacity. And I know there are 301 seats in the theater. And they didn't say that they had a full house, but for this problem, let's assume every seat is filled. That means X plus Y plus Z equals 301. Okay, that's our first equation. The second equation is the money, okay, for the seats. We know a child's ticket is $5, so 5X is the amount of money we take in from the children's tickets. And then we have the adult tickets, which I think are 12. Okay, and then we have the student tickets, which are 7. And the total box office for this was $21.80. There's our second equation. Okay, the third equation is this ratio equation. There are half as many adults as there are children. Another way to say that is there's twice as many kids as adults. Okay. So everybody kind of gets this messed up. Okay. Twice as many kids as adults. So the number of kids is twice the number of adults. Okay, everybody gets it backwards for some reason. Okay, just look at the equation you come up with and put in test numbers. Okay, if there are 10 children, that means if there are 10 adults, there are 20 children, right? So if I put a 10 in for Y, I get a 20 out for X. Make sure you have the sense of this the right way. Okay, because English is not in the same order as math as a rule. Okay. Now, if you want to make an equation out of this that's in the same X, Y, and Z format, that means you've got X, you've got to get the 2Y on the other side, so it's going to be negative. You got no Z's, and the right-hand side is also 0, right? If I subtracted 2Y from here, I'd get X minus 2Y plus 0Z equals 0. Okay, so there are your three equations. Okay. Anybody questions on the setup? I'm not going to solve it because again, solving just requires you to take the coefficients and the right-hand side out of here, put it in a matrix, put it in Symbolab. Okay, any questions on setting up 2? Okay, let's look at 3. 3 is a mixture problem, and I have nickels, dimes, and quarters. So again, I have 3 variables. I'm going to call them N, D, and Q. You can call them X, Y, and Z. You can call them whatever you want. Okay. So the first question is how many equations do we need? We need 3. Okay. So it says a collection of nickels, dimes, and quarters consists of 10 coins. So we have a count equation. Okay. And again, X plus Y plus C equals 10. Okay. Then they give us a value. Okay. And again, you have to decide, do you want this in dollars? Okay. It doesn't matter. They want counts. Okay. So I'm going to basically say a nickel is 0.5 times X. A dime is 0.10 Y. These are the values. Okay. So I'm taking the value of each coin and multiplying by how many I have. All right. That's a total of 1.45. If you don't like the decimal points, you can change this to 5, 10, and 25, but then change this to 145. Okay, multiply everything by 100 if you don't like the decimal points. You're going to do it with a calculator, so it doesn't matter. Okay. The last one is this ratio. The number of dimes is equal to the number of nickels. Okay, so that's saying Y, X is equal to Y. Okay, to get an equation out of that, okay, you'd have to subtract the Y from both sides the same way. And that would give you X minus Y plus 0Z equals 0. Okay, everybody right with that one? Okay, again, not going to solve it because all it involves is taking a matrix out of, making a matrix out of your coefficients and right-hand sides and putting it in Symbolab. Okay, so is everybody okay on 2 and 3? Any questions on 2 and 3? Okay, can I just get a vote from the group? Yes or no? Questions on 2 or 3? Okay.
No questions.
All right, excellent. Let's quickly go through what else we have here. Okay, so these are probability questions. Okay, this is a probability involving ORs. Okay, this is a probability involving conditional probability. We'll come back to these. This is an expected value question. Okay, so basically you have to find, list all the possible outcomes in the probability distribution for this event and multiply them by their probabilities to get the expected value. Okay, so let's go back here. All right, this is again a probability question kind of involving and. Okay, let's see what I've got here. I'm up to 11. And then this one, number 11, this one is strictly getting mean, median, mode, range. In your course, and let me go back here and just show everybody, okay, where all the calculators are. Remember, here's week 16 where we are. If you just scroll down past final exam and complete textbooks, see online tools and calculators, general stuff like Desmos, Symbolab, Desmos, Gauss-Jordan elimination. Here are probability calculators, descriptive stats. This is the one I would use for question number 11. Okay, put in your data and just hit descriptive stats, and it will give you the mean, the median, the mode, all that good stuff. Okay, range is easy. Range is the highest and lowest. Okay, mode is going to be the number that happens the most frequently in this distribution. That's the one that occurs 12 times, 31. So these you can do just by looking at the table, mean and median, use the one variable statistics calculator. Okay, same thing for number 12, calculate the standard deviation. Don't do it by hand. Use the descriptive statistics calculator. Make sure you're looking at sample standard deviation. Okay, let's look at number 13. Okay, number 13 is asking a question. It's saying, is this a probability distribution? Okay, I kind of hate yes, no questions because there's very little work you can show. On this question, what you're checking is, are all the probabilities between 0 and 1? You may want to write that down in your work, saying all probabilities are between 0 and 1. And if I add these probabilities up, they sum to 1. Show me that, okay? And then that way, if you inadvertently click the wrong button, okay, I can give you all the points. If you don't show me anything, I don't know what you were thinking, okay? This is a probability distribution. All the probabilities are valid probabilities between 0 and 1. And if you add this column up, you'll see it sums to 1. So this one's definitely a yes. Okay. All right. Rest here are normal distribution. Calculations 14 and 15 are normal distribution calculations. Okay, use the normal distribution calculator I put in that course tools section. Okay, basically, I'll show you how to set it up. We'll come back and we'll use the calculator. There's also a z-score calculator, even though z-score calculations are pretty simple. Okay, if you look at this one, if in a normal distribution, a data located one standard deviation below the mean has a standard z-score of -1, okay? Same thing for this, 2.3. This one, the mean has a standard score of 0, okay? So basically, this is just trying to figure out if you know what a z-score is telling you. It's telling you where that value occurs in a standard distribution. How far away from the mean is it in terms of standard deviations? Okay. This one, and for some odd reason that I can't explain, this function is written in calculator notation. I apologize for that. Just be very careful when you copy, okay? All you're doing here is evaluating at x is 2, y is 5, and z is 2, okay? Just figure out what the value is. It's strictly a calculator problem. Okay, now we are finally into the stuff that has to do with multivariable calculus. We have a function here. And again, I apologize for the calculator notation. I'm not sure why it rendered that way. Okay, I think that's a function of what happened when I printed it off. Okay, but I'll write this in standard mathematical notation and we'll figure out the partial derivatives. Okay, so this is just, can you do the partial derivatives with respect to x and y and z? Okay. All right, now finally, question 18 and question 19 and 20, I think, are the ones that are word problems. So we're going to start with those, and then we'll go back and we'll do the ones you want to see in whatever order you want to see. Just remember, I'm going to upload all of my notes, and I've completed all these problems. I worked them all out, and I'll upload all of that work so you can see whichever one you're interested in. Okay, so here, a flight instructor you're a flight instructor and you train private instrument and commercial students. You've determined your hourly cost can be modeled by a function of three variables, X, Y, and Z, where X is the number of private, Y is the number of instrument, and Z is the number of commercial students. If you're currently training 5 private, 6 instrument, and 6 commercial students, determine the following. Okay, there is only one interpretation thing in this problem. Okay, we've already been told what X, Y, and Z represent. We don't need to figure that out. They want to know the additional hourly cost in each of these problems of training just one more. Okay, can anybody tell me what is that telling me to do? Okay, so what is problem 18 asking?
Take the partial derivative with respect to X, Y, and Z.
Yes, okay. Now, basically, this additional hourly cost of one more of each type is asking you for the marginal cost. Okay, that's what marginal cost means, all right? And marginal cost means take a derivative, okay? So in our first example, I want to take the partial derivative of cost with respect to X, which basically means I'm going to treat Y and Z as constants, okay? And I'm going to differentiate this equation up here with respect to X. If X is the only variable, okay, when I differentiate here, X turns into a 1, and 17.4 Y and Z come across as just coefficients. Okay, so there's my partial derivative, all right? And then what I have to do is evaluate it for the values they gave me. So 17.4, put in a 4 for the number of private. Okay, so Y is private. And then I have to put in 6 for the number of commercial students and evaluate that with a calculator. Just multiply it together. Okay, so it would cost me $417.60 to train one more private student. Okay, the others are exactly the same, except the derivatives are different. This is a really easy function to differentiate. Now I'm choosing Y as the variable that I'm differentiating with respect to. So the X and the Z, and of course the 17.4, come across as constants, right? They're not constants, but coefficients, okay? And likewise, I'm going to evaluate them, and I'm plugging in a 5 for X and 6 for Z. This gives me 522 even. Okay, so it cost me $522 to train one more instrument student. And the last one here is take the partial derivative with respect to Z. Now, Z is the variable I'm differentiating with respect to. So the 17.4 X and Y come over to the derivative as coefficients, right? And then I'm just going to plug in those values. Okay, so here X is 5 and Y is 4. And that gives me 348 as the cost to train one more commercial student. Okay, so the only difficult part of this question, aside from doing the partial derivatives, and this really isn't a hard problem, is understanding what this additional hourly cost of just one more is asking you to do. Okay, so questions on 18? Anybody have questions on 18?
No questions.
All righty. Okay, so let us move on. Okay, these are, let's take a look at. Okay, Crested Butte Bike Company, I seem to remember this one from the homework, rents 2 lines of mountain bikes, Rugged Extreme and Flatlander. I guess I'd rent the Flatlander. The weekly cost of its maintenance repair shop is given by C of XY. And again, one of these, I'm sorry about the way this is rendered. Let's see if I can write it better so it looks more normal. So that's 7917 plus 47x squared plus 80y squared minus 566x minus 465y. Okay, so there's our cost equation. And in this example, we have X is the number of rugged bikes and Y is the number of flatlanders. Trying to get it to show up. Okay, so if you have to, again, I'm thinking that when you actually take the practice exam, it will render these equations correctly, right? So they're asking me, determine the number of each bike the company must repair to keep its cost to a minimum. Okay, so costs to a minimum. So what this question is asking me to do, it's asking for the minimum of C of XY. Okay, it's a function of two variables. So if you remember how you have to do this, okay, there's no constraint in this equation. So it's not a Lagrange problem. It's a strict figure out where the first derivatives are zero. Okay, that gives you your critical point. And then use the discriminant, that D thing, okay, that involves partial derivatives. Use that to determine whether you've got a max or a min. Okay, so let's partially differentiate with respect to X. So I'm going to look at this equation up here. I wish I could get this out of the way. Okay, I don't know why that keeps popping down like that. There you go. Okay, so I'm differentiating C of XY with respect to X. Anything that has an X in it, like 47x squared and 566x, will give me a term in here. Luckily, there are no XY terms, so this is a really easy equation to partially differentiate. The 7917 is going to give me a 0 in my derivative. Okay, so again, to differentiate this, I'm just going to use the power rule on any of the terms that have X in them. Okay, so I'm going to bring down the 2 and multiply the 47 by that. That will give me 94x. And then I'm going to bring down the 1 on negative 566x. That'll give me negative 566 times x0. So my partial derivative with respect to x is this. Okay. Likewise, my partial derivative with respect to y is similar. I'm just going to differentiate the y terms, bring down the 2, multiply the 80 by it, drop the exponent by 1. Okay, and the other term with a y in it is negative 465y. That gives me negative 465. Now I have to set both of these to 0. Okay, they're simple linear equations. Okay, and I'm sorry I put a y in here instead of an x. Okay, these are just going to be easy to solve. Okay, so here I get 94x equals 566. Okay, and when you figure that out, that gives you, let's see, x is 283 over 47. Okay, that's what it is. It's a fraction. Okay, and the second equation gives me 160y equals 465. And when I solve that out, I get y is 93 over 32. Okay, so my critical point, okay, is 283 over 47, comma, 93 over 32. Okay, so remember, this is a point, if you're thinking in terms of a graphical representation of this, your XY plane is on the floor. and your cost surface is hovering in space above the XY plane. Okay, we've located this XY point on the floor, and we're trying to determine if the Z value above it, the point on the surface, is a maximum or a minimum. Okay, we're hoping it is a minimum. Okay, now again, what they're going to ask you to do here, okay, is they're going to ask you to round these values, okay? Because again, it doesn't make sense to say I have 283 divided by 47 bikes, okay? This is about 6.02, okay? And the Y value, 93 over 32, is 2.9. Okay, so we're gonna, when we actually come up with an answer, once we prove this is a minimum, we're gonna round to the nearest values. They don't tell you to do that. Okay, I'm telling you to do that. Okay, because again, putting in 283 over 47 bikes sounds a little weird. Okay, these are approximately close. This number's close to 6, that number's close to 3. Okay, but I still need to figure out whether this point here, this critical point gives rise to a max or a min. Okay, so what I need to do is I need to find the second partials. Okay, these are going to be constants. Okay, because again, if I differentiate C of X one more time with respect to X, I lose the 566 and I get 94. Okay, if I differentiate C sub Y one more time with respect to Y, I lose the 465, get 160. Okay, and then the only thing I need is a mixed partial. Okay, and you can see there are no Y's in this equation. So this is a constant term and that's a constant term. So my mixed partial derivative is 0. Okay, then if I build a discriminant, that's CX times CYY minus CXY squared. Okay, and if I plug those values in, 94 times 160 minus 0. The only thing I care is about the sign. Okay, this is greater than 0. Okay, that means I have a max or a min. It's not a saddle point. Realize that these critical points, these values that you get in the XY plane, can give rise to maxima, minima, saddle points. Okay, so you have to check to see what you've got. Okay, the first step in checking is that this value D is greater than 0. That means you've got a max or a min. And then you look at the sign on CXX is greater than 0. Okay, and again, a positive second derivative means concave up. Okay, concave up means you are sitting down here in the middle of the smile. Okay, so this proves you have a minimum. Okay, that is the calculus required to get the answer. Will some people cut to the chase and just assume this is what you were asked for? Sure. Okay, that's typically the way stupid math book problems work. But if you're doing this in the real world, remember, there's no answer key. You're not going to know whether or not it's really a max or a min till you check. And can you check graphically? Yeah, as long as you've got decent software that can render a 3D surface. Wolfram Alpha is a little sketchy. Okay, I have really a tough time finding locations on the surface in Wolfram Alpha. Okay, so it's not that great. So what I would say is the number of extreme bikes repaired is 6. The number of Flatlander bikes is 3. And then if I wanted to figure out the minimum cost, I would plug X equals 6, Y equals 3 into this equation, and I would get a minimum cost of 5,338. Okay, and again, what I'm telling you here is round to whole numbers. They don't put directions. So again, if you carry more, the way more works is if you give it more decimal places than it wants, it's happy, pretty much. Okay, so if you're more accurate than it's asking for, usually it'll mark it right. If you put in less accuracy than it's asking for, that's when it marks it wrong. Okay, so I'm telling you on this crested butte problem, round your stuff to whole numbers. Okay, so questions on 19. Anybody a question on 19?
No
No?
questions.
Okay, let's take a look at this one. Okay, so basically it says we have to fence a rectangular vegetable patch where the barn forms the northern boundary. Okay, so basically what I took from that to be, okay, here you're going to get treated to my horrendous drawing. Okay, so here's the barn. Here's the barn. Okay, and the vegetable patch has one side of the barn as its northern boundary. And then I'm assuming it goes like this. Okay, so what I took away from that was you don't need a fence if the barn's in the way, right? So I'm only going to fence 3 sides of this thing. Okay, that was what I took away. Okay, because again, if the barn's in the way, nothing's going to get into the vegetable patch from that side. Okay, there were problems like this in the homework. The fencing for, here, let's put north, south, east, west. Okay, so the fencing for the west and east sides is $3 a foot, and the fencing for this side is $7 a foot. I don't know why it would be more expensive for this side. Maybe this side goes up against a road and you want this side to be stronger. Who knows? Okay. So let's call this side Y and this side X. Okay. It's a rectangle, even though I've drawn it so it looks like it's got perspective. Okay. You know that this side has to be Y as well, right? And we're saying we don't need another fence on the north side. Okay. So they're telling us that, again, each one of these Ys is going to cost me $3. Okay. And this X is going to cost me $7. Okay. Roger has a budget of 120 for the project. What's the largest area Roger can enclose and what are its dimensions? Use the method of Lagrange multipliers. Okay. And they say round to the nearest hundredth. Okay. Well, again, it's area. Okay. So you have to think, okay, so that means I have something I'm trying to maximize or minimize. That's given to you here. What's the largest area Roger can enclose? Okay. So this is going to be your objective function. So I'm going to ask you, say in words, what's the objective? Tell me in words, what's the objective? What am I trying to do here?
You're trying to get the most amount of fencing for $120.
Nope. Okay. This is why these are tricky. What's the largest area? You're trying to maximize the area of this rectangle. Okay. This is part of your constraint. Okay. So look for the question in these Lagrange problems. It'll say, what can I, what's the lowest cost? What's the largest area? What's the most profit? Okay. So again, look for the question. The area of a rectangle is length times width. In my example, that's X times Y. So when they're asking for an objective up here, you're going to say f of xy is xy, because that's an expression for the area, and you're trying to maximize it. Okay, remember, Lagrange by itself will not tell you whether you have a maximum or a minimum. It'll tell you that this is an extreme point and it meets your criteria. What I told you is in this class anyway, just assume if we can find a critical point that meets our criteria, our constraint, we're going to assume that this is the solution we're looking for. Okay? So that's our objective. Okay? Now we got to figure out our constraint. Well, obviously, our constraint is the budget. Okay, so budget is the constraint. Okay. The other thing you have to remember is if you're putting a fence around an area, is that, is the fence length related to the area? Well, yeah, in a way, but it's more related to the perimeter around whatever you're fencing in. Okay. So you have to basically say cost of perimeter fence has to equal 120. Okay, that's basically what we're trying to figure out. And remember, we're going around 3 sides of this thing. Okay, so the cost of our perimeter fence, they said the long sides were $3 a foot. So 3 times Y, where Y is the number of feet. Okay, the short side was $7 a foot. Okay, so 7 times X, where X is the number of feet, and another 3Y. Okay, for the third side equals 120. Okay, I can combine like terms and get 6y plus 7x equals 120. This is my constraint. Okay, now again, this needs to be with a 0 on one side. So 6y plus 7x minus 120 equals g of x, y. Okay. Anybody questions on how I got the constraint? Okay, so that goes here. Right? And pretty much you can do this in the method of Lagrange multipliers. Okay, I will show you how to do it by hand first, and then I'm going to show you how I solve this with Excel, because that's what you're going to do in the real world. Okay, so here's the Lagrange multiplier method. You build the Lagrange function, x, y, lambda, and that's your objective function. Okay, remember this can be plus or minus. I happen to use minus. You can use plus as well, that will work. Okay, and then you put your Lagrange function. Okay, so here's the objective and the constraint. Again, if you do it by hand, I know the notes say use a plus. I learned this using a minus, and I just can't force myself to put a plus in there. I'm sorry. It'll work. Okay, and then you have this. I'm distributing my minus sign. Okay, then you take your partial derivatives with respect to each of your variables, x, y, and lambda. Okay, so remember when you do this, only the terms with an x in them will give you anything. Okay, and every other variable comes across as a constant. Same thing with y. I've got 2 terms with y in them. Okay, so this is going to give me x minus, no, wait. And then 6. I got my variables backwards. That's what happened. Okay, the 6 goes with y. Sorry. I'm wondering why this is not working out. Okay, I copied it wrong. Okay, it's 6y plus 7x. If you do that on the final and you show me your work, like if I can tell you made a transposition or a copying error, I will give you most of the points. I will also work out the problem with your numbers and see that I get the answer that you got. Okay, that's why it takes me so long to grade exams. Okay, I'm trying to figure out what you're thinking. Okay, transposition errors happen. Okay, but I noticed I had a problem down here, so I went back and I looked. So 6y plus 7x minus 120. I had transposed my x's and y's. Okay, so this is going to give me okay, now we're good to go. Now this one changes from 7. Yep, and this now is 6, and now it makes sense to me. Okay. And then the last partial derivative is with respect to lambda. And that'll be something I get from the last 3. Okay, plus 120. Okay, everybody understand the partial derivatives with respect to x, y, and lambda? Okay, with partial derivatives. Anybody problems with these?
No
Okay.
question.
No questions. Okay, what's good about this is these 3 equations are all linear in x, y, and lambda. Okay, so basically, if you were to transpose them into a matrix, you would get, okay, there's no x's, there's one y, and there are -7 lambdas, and the right-hand side is 0. Okay, so basically, these are all set to 0. Okay, so you can get your critical point. Okay, this one has an x, -6 y's. No lambdas, no y's. So this is 0, 1, 0. This one's got a 0 for y, -6 for lambda, and a 0 here. And this one has, if I get everything on the other side, I'm going to get +7x plus 6y plus 0 lambda equals 120. So this will be 7, 6, 0, 120. Okay, and then you can put this in Symbolab. Okay, to solve it. And it'll basically give you values. Okay, it'll say x is approximately 8.57, y is approximately 10. It's actually equal 10 on the nose. And lambda, they don't care about. Okay, they just want the dimensions. Okay, so basically they told you to round to the nearest hundredths. So you'd say 8.57, 10. Okay, and then if you multiply these together, you get 85.71. Okay, you need an extra position here on your x so that you can round the area to the nearest hundredth. Okay, so this is doing it all by hand, but let me show it to you in Excel. Okay, I have to share my spreadsheet with you. Okay, so let me just share that. Okay, everybody should see this. Okay, so here's 20. Okay, I'll start it out from scratch so you can see how I did it. Okay, here's my variables. Okay, the variables that I'm interested in optimizing, my decision variables. My objective is the area. Okay, maximize, I can even say maximize area. Okay, and here's the area formula, x times y. Here's the constraint. Okay, I have 3 times 2 times A, that's 6. I could say 6 times A1, okay? Plus 7 times A2 is my constraint, okay? And then if you wanted to, you can basically put the constraint value over here. Okay, I went and screwed it up. Undo. I screwed up my formula. See, this is what happens when you type in a cell. Okay, so this was 6 times A1, 6 times, try to figure out what I've got here. 6 times Y plus 7 times X tab. Okay, so there's my constraint formula. Okay, and if you wanted to put a value over here, I'm going to just try to make this column a little wider. You could say this has to be $120. Remember, this is the cost of the perimeter fence. Okay. Now, when you're using, this is a desktop Excel spreadsheet. Okay. I need to set it up like this if I were using Excel 365. Okay. And remember, you're going to open up the window on the side. Here are your decision variables. Here's your objective function. Here's your constraint cell, and this is the value you need to maximize the constraint set to. Okay, that's a little different in Excel 365. In case any of you have desktop Excel, okay, here's the way the solver looks on that. Okay, I'm setting the objective to cell A5. You can see it's highlighted. I'm changing the variable cells just by clicking and dragging. Okay, so let me highlight that, click and drag, and you see the range there. Okay, for this one, okay, if I say change, just so you can see it, here's the constraint, the cell reference, set this to equal, and you get to type in the constraint value in desktop Excel. And then you say, okay, make sure you're choosing a nonlinear method for solving because this is not a linear equation. And then click solve. And you can see I get the 8.571, y is 10, and here's your value of your area. Okay, so you're maximizing your area at 85.71. Okay, so questions on the Excel version. Anybody questions on the Excel version of this? This means you don't need to do all that partial differentiation. Okay, as long as you can identify the objective and the constraint, the f of x and the g of xy, you can use Excel. And yes, I want you to do that, okay? Because that's what's important to know how to do. It's great that you understand the mathematics behind it with the partial derivatives and all, okay? That's, believe it or not, that's not exactly what Excel is doing. It's doing some more of a numerical analysis type of a solution, okay? But you're going to have to use Excel to do these types of optimizations, okay? So I'm asking, anybody questions on this one? Okay, any questions at all on the, I think we're done with the word problems. So
Yeah, that was helpful. Thank you.
you're welcome. All right, so what I'd like to do, if that's okay with you, is we'll quickly go through the review one more time from the beginning, and you tell me which ones you actually want to see worked out. We can actually vote, okay? Anybody want to see number 1? Okay, again, the algebraic method we are using is we are building a matrix from this, and we are putting it in Symbolab. Anybody want to see this?
I think that's pretty straightforward.
It's very straightforward, okay? As long as everybody is comfortable with using that Symbolab matrix solver, that's what you got. If you like your TI-84, the TI-84 will do this as well. Put this matrix in matrix A, and then just do RREF, okay? All right, anybody want to see the solving of this? Again, we have a matrix that we created from our equations. And we're just going to solve that with Symbolab. The only thing that was hard about this one is getting that last equation correct. All right, so we're good with that one. All right, 3 is very similar. The hard work was coming up with the equations. Then you just put them in a matrix. And symbol lab. Okay, everybody good with that? All right. Okay. This one says, given the matrices A and B, it is possible or not possible to multiply these. What do you think? Can I multiply these matrices?
Yes.
Yes. Okay. The way you check is you figure out how many rows. This is rows and columns. And as long as you can get a match in the middle, okay, the number of columns in the first equals the number of rows in the second, you can multiply. So you would say it is possible. Okay, and then if you use the Symbolab matrix calculator, you just put the two matrices next to each other, okay, and say solve, and it will give you the values to put in here. Okay, so again, use Symbolab. Okay, if you're doing this by hand, you multiply each row by each one of the columns, okay, and that'll give you the first row and so forth. But don't do it by hand, there's tools, and they're a lot less error prone. The only thing you have to make sure you're doing correctly is you're typing in the matrices correctly, so double check your work. The TI-84 will do this as well. Type in matrix A, matrix B, and just put them next to each other using the names list out of matrices, and the calculator will know you mean matrix multiplication. Okay? Again, I'm assuming we're good with this. All right. Now, here we have our first linear programming problem. Okay? Now, the way they probably expect you to do this is graphically, okay, where you would graph these three inequalities. You would find the corner points of the feasibility region that's created by them. And then you would evaluate this function P at each of the corner points. Okay, so we can do it that way, or we can use Excel. Okay, so I'm asking you a question. Should we do this graphically or use Excel?
Excel.
Excel. Anybody want to see it graphically? Okay. Again, I've kind of used desktop Excel only because I am, you know, it's a little bit less painful to use than Excel 365, but the basics of it are correct, of the same. Okay, so here's number 5. And again, I will upload this worksheet with my notes so you can take a look at the worksheet. Okay. So again, this one says, I want to maximize this objective. Okay, so the objective is 2 times X plus 3 times Y plus 5 times Z. Okay, and X, Y, and Z are here. Okay, so I'm going to start out by clearing these out. All right, and then here's the objective formula. I have 3 constraints. Okay, 2X plus 2Y plus Z. Okay, and again, I'm just going to widen this, and I'll put the right-hand sides in of these. This is 10, less than or equal 10. This one is less than or equal 15. I'm putting them in, so in case you're using Excel 365, you know what the right-hand sides are. Okay, because that's a little different. Okay, remember, they can't have these less than or equals. As a matter of fact, let me do it like this. And I'll put the values over here. Okay, that way you can just use these cells if you're using the Excel 365. You can, folks, you can actually copy this and like paste it into the Excel 365 spreadsheet. Okay, so again, you can kind of transfer stuff between desktop Excel and Excel 365 that way using your clipboard. Okay, so we'll just fix this. Okay, and so everybody comfortable with the constraints I've typed in? There's the last one. Okay, here's my objective. I'm going to bring up the solver. So that's on my data tab. Okay, my objective is set. I have the variable cells. I want to make sure I'm maximizing. Make sure you pick the right objective, maximizing or minimize. Here are my constraints, and I have the right-hand sides typed in here already. This one I'm picking simplex LP because these inequalities are all linear. And then solve. Okay, I'm going to keep the solver solution. You can see my variables of X, Y, and Z are 3, 0, and 4. And the value that I maximized the objective to was 26. Okay, so when you go back to your notes, this is the way you're going to type it in. Okay, it will work graphically. Okay, but again, the idea behind Excel is it's faster. Okay, anybody questions about this one? Okay. Now we're into the probability stuff. Again, if you've got questions at any point, just stop me. Just say, excuse me, question, okay, and we'll stop. So here we have a list of, I guess, exam grades, okay, and they've been kind enough to total up the number of males and females, as well as the number of A's, B's, and C's. And you can see this total row and this total column sum to 72. So this is the number of people who took the test. Okay, if they don't give you those total rows and columns, you figure them out. Okay, you're just summing up each column, right? So 12 plus 6 is 18, 8 plus 19 is 27, and so forth. Okay, so if I choose a student at random from this pool, find the probability the student got a B. Well, I already know the denominator is 72. Okay, and then I find the total of the number of B's, which is 27. 27 over 72. Again, I think it expects it is either a reduced fraction or a decimal. So you're going to type in 3.8, or as a decimal, this is 0.375. Okay. Please reduce your fractions if you're going to do fractions. Okay. Or more likely, just take your calculator, type 27 divided by 72, and type in the 0.375. Okay, don't mess with reducing fractions if it's not required. Good with this one? Okay, the next one, number 7. We have this a similar table. The numbers are different, but they're summed the same way. Okay. And we're saying find the probability if we pick a student at random that the student was female or got a C. So you have to remember the probability of female or C is the probability of females plus the probability of C's minus the probability that females and C's occurred. Okay, so you have to remember the formula for the probability of a union. And again, it's the probability of each alternative minus the probability that both happened, because you've counted this overlap in each one of these. That's why you have to subtract it. Okay, so if I want the probability that I pick a woman, okay, all these denominators are 64, so I can put those in right away. And then I just have to pick the right numerators. So I find the total number of women is 39. Okay, the total number of people who got C's, that is 16. And then the women who got C's are these 14 people right here. Okay, so it's more of an exercise in being able to read the table correctly. Okay, and then remember how to add and subtract fractions. Just add and subtract quantities in the numerator. Okay, and this gives me 41 over 64. Okay, which if you want to render it as a decimal, again, this loves decimals for some reason. Okay, this is an exact decimal representation of this, so I put in all the decimal points. It probably will be okay with 41 divided by 64 as a fraction. Again, if you show me this work and you get this and it didn't like what you typed in, I'll give you all the points. But show me what you did. Okay? Number 8 is a conditional probability. Now, what you need to remember about conditional probabilities, you can see we have the same type of table. Here's the total number of people who took the test. Conditional probabilities restrict your sample space, okay, to whatever the given that was, okay? So the first event shrinks your sample space down. So this says, find the probability the student got a C given that they're male. So we're not going to consider all 86 people. We're only going to consider the men, okay? So we're looking at 47 as our denominator, right? Because we're only interested in men. Okay, and then of the men, 16 of them got C's. Okay, and as a decimal, this is 0.340. Okay, is everybody comfortable with the whole conditional probability thing from the table? If they had said, given that the student was a female, my denominator would have been 39 instead of 47. Okay. All righty. Number 9 is an expected value question. It says a company estimates that 0.9%, let's render that as a decimal, 0.9% of their products will fail after the original warranty period, but within 2 years of purchase. And the replacement cost for the product is $500. If they offer a 2-year warranty at a cost of $60 to the customer, what's the company's expected value of each warranty sold? Remember, the company wants to make money selling you warranties, just like any insurance. You as the consumer hope, yeah, I'll shell out the $60. I hope I never need it. Okay. So expected value. First, let's consider what our alternatives are. Okay. We have the probability that our product fails. Okay. So the value then, let's do it like this, value and then probability. Okay, so we might have our product fail, in which case they're going to give us the $500 replacement, but we're out $60 for the warranty. Okay, now the probability that that happens within a 2-year period is that 0.9%. Okay. The other probability is that our product doesn't fail. In that case, we're out the $60 for the warranty and we don't get anything back for it. And then we have to figure out what that probability is. So it's 1 minus 0.009, which is 0.991. Okay, everybody good with that? There's no other choice. Either the product fails or it doesn't within the 2-year period. Okay, so our expected value of X is 500 minus 60 times 0.009 plus negative 60 times 0.991. Okay, so I'm just pulling the things out of the table and adding them together. And I'm going to evaluate that expression on the right in a calculator. Now remember, this is from the customer's point of view. Okay, the expected value that comes out of this is negative 55.50. Okay, so if I get enough customers together who buy the warranty, on average, each one of them's out $55.50. They are asking me for the company's expected value. Okay, remember I told you there's two sides to every transaction. The company hopes to make $55.50 on each one of these warranties. Okay? So yeah, they're selling them for 60 bucks, but they're only going to have to replace a very small percentage of the product. So almost all of the cost of the warranty is pure profit to the company. Okay, so any questions on 9? You understand why it's positive? Why I put a positive number in there? Okay. All righty. Number 10, a die is rolled 2 times. Okay, what is the probability of showing a 6 on every roll? Well, you know, the probability of getting a 6 on a fair die is 1 out of 6, 1/6. Okay, these are independent events, namely one roll doesn't affect another. So you can just do this. Okay, and as a decimal, this is 0.0278. You can also do this with a binomial probability. All right, and there's a binomial calculator in your course. Okay, and here your N is 2, your P is 1/6, and you are looking for 2 successes. Okay, so basically either one of these will give you the same value. Again, because these are independent events. Okay, the reason I decided to do it the quick and dirty way was my N and my X were very small numbers. If this was 10 and that was 8, I would have used the binomial calculator rather than multiply a whole mess of things out. Okay. Does anybody want to see me use the, anybody want to see using the one variable calculator on number 11? Anybody want to see that? Is everybody comfortable? They know how to use that? Again, you're doing this on a calculator. Okay, to get the mean and the median. All right. When I show you this, I can, show you how to do it by hand, but what's the point? Okay, use the calculator. I want to see how many we have left that I need to show you. Okay, let me show you this calculator really quick. Okay, just to make sure everybody's comfortable with it. So I'm going back to our course. Here's the descriptive stats calculator. All right, so entering the data set. Okay, I should, with the one that I showed you, 328s, 1129s, 530s, 1231s, and 632s. So you need to actually type them in like this. Okay, so 28, 28, 28. It's tedious, but it will. Okay, if you've got a TI-84, on the other hand, let me go back to my worksheet and bring up the TI-84 and share that with you. Okay, so you are going to do this. You are going to use your lists. So go into Stat Edit, okay, and then put your values in the first list. And then put the frequencies in the second list. Again, I don't know how many of you have a TI-84 handy. So again, the calculator I gave you is tedious, but it will work. Okay, the TI is much better. Okay, and then you want to go to second that's lists. Nope, sorry, quit. Stat, calc. One variable statistics. And put L1 in the list with the data. And then L2, which is second to, is your frequency list. Calculate. Okay, here's your sample mean, 30.32. If you scroll down, the median is 31. Okay, and like I said before, the mode and the range you can tell right from the table. Okay, so the mode is the most common score. That would be 31. So I'm putting in the values that I'm getting here. Okay, and this was 31. The mode is 31 as well. 30 rather was the median, sorry. Okay, so this is telling me the median's 31. Okay, median's 31 then. I hope I typed everything in right. Okay, and the range is the difference between your high and your low scores. Okay, so this is 28 from 32. So this would be 4. Okay, again, it's just a matter of making sure that you type things in correctly. Okay, so again, this is saying the median's 31, but I know when I did it before, I got a slightly different answer. So let me just check my lists. 3, 11, 5, 12, 6, 28, 29. See, I typed 31 twice. That'll screw it up. So 30. Okay, enter. Try it again. And that was stat, calc, one variable stats. And now 30.19. And now the median is 30, which is what I got. Okay, mode, again, I'm eyeballing. Okay, so everybody understand how to use both calculators? Okay, again, I'm not sure who has what, so if you've got questions, please ask. All right. Also, if you scroll on down here, I mean up here, I want to point this out, especially on the TI-84. This is important, TI-84 users. S of X, S sub X, this is your sample standard deviation. This is a population standard deviation. Notice that they're different. Okay, remember the Greek letters have to do with population. So mu is a population mean, sigma is a population standard deviation. These are giving you samples. So make sure if they're asking for a sample standard deviation, you're using the S. All right, so sample standard deviation. Okay, let me minimize the TI. Okay, and move over here. Okay, the next question again is just asking for a sample standard deviation. So again, what I would try to do is to type these values into my online calculator or my TI and use the one variable stats. So I'm going to show you this one since I don't have to type a lot of repeated numbers. Okay, so there's my sample. I'm just checking that I have 6 scores. It says sample, calculate. This is asking me for sample standard. So this 6 second is be 5.64. Okay. All right, so let's go 5.64. Okay, so a manufacturer knows their items have a normally distributed length with a mean. This is mu, population mean, and a standard deviation. This is a population standard deviation. And they want to know the probability of finding an item less than 7 inches. Okay, so 7. Yes, on a continuum, right? Basically, here's your mean, 6.1. Here's 7. You want to know the probability of any of this, right? To the left of 7. So that's all the way to negative infinity. Okay. If I use the online calculator, I don't need to worry about faking out a negative infinity, both the TI and the online calculator. So again, let me try to close this one and get to the close. So I'll have to just open up another tab. Okay, so let's go down here. So I'm trying to get to my calculators and online stuff. Here it is. Okay, so probability, normal probability calculator. I'm going to click on that one. Okay. And again, they gave me the mean size of one of their items was 6.1 inches. And the standard deviation was 0.6. And now I want to know that what's the probability of being below 7 inches? Okay, what's nice about this is they actually give you a picture of the probability distribution. So you can see, oh yeah, here's the mean. Okay, and this is from slightly more than 1 standard deviation above all the way over. So I'd expect this to be a pretty large number. Okay, here's the probability down here, 0.9332. Okay, on the TI-84, if I want to do this, I'm going to clear this, turn it on again, clear. I have to use normal CDF on my distribution. So second, vars, normal CDF. Okay, I'm going all the way to the left on the curve. So I need negative 1E99. Let me clear this and type it in again. Negative 1. The E is this shift on the comma. So second comma 99. That's a really negative number, and it fakes the calculator out into thinking negative infinity. The largest value I'm interested in is 7. Okay, the mean is 6.1. And the standard deviation is 0.6. Okay, paste that into your window and hit enter. Okay, the only advantage to the TI is you get a lot more decimal places. This gives you 4. For most applications, 4 is plenty of decimal places. Okay, but you can see here, this 9 would round this to a 2. So we're getting the same value. Okay, everybody all right on the normal one? Okay, with normal probability. I really like this online calculator. It's not clunky like the one variable statistics one. So I recommend this one. Because again, 4 decimal places is usually all you need. Okay, so again, all I would do here is put the 0.9332. Make sure you round it correctly. We kind of talked about this one before. In a normal distribution, a data value, 1 standard deviation below the mean has a z-score of -1. Okay, that's what the z-score is telling you, is how many standard deviations either side of the mean is this value. A data value located 2.3 above the mean has a z-score of 2.3, and a mean has a z-score of 0. Okay, because it's right in the middle of the distribution. Okay, again, this function is 6 times x cubed y minus 12yz squared plus 4x squared z. Okay, again, as I said before, it rendered strangely when I printed it. I think it will be okay in the quiz. So all you need to do with this is plug in the X, Y, and Z values they give you. Okay, and evaluate it on a calculator. Okay, and it's just a strict evaluated on a calculator. I got a 32. All right, so it's not asking you to do anything strange. Okay. The last one I want to show you is this one. Okay, and we're almost finished. So yay, we made it. Okay, let me rewrite this so it's a little bit easier to see. Okay, so this is a function of three variables, X, Y, and Z. Okay, and they're asking us to differentiate it. Okay, now it's a little trickier when you've got multiple variables and when you've got exponentials as well as when you've got linears in here. Okay, so let's first differentiate with respect to X. If I differentiate this first term with respect to X, the X turns into a 1. The 8 and the exponential come along as coefficients. So this would be 8 e to the yz. Okay? And if I differentiate the second term with respect to X, the only X is up here in this exponent. Okay? So basically what you're going to get is the 10y comes along as a coefficient, but then you've got to figure out how to differentiate this as if z was a coefficient on x. So if this was e to the 4x, the derivative of it would be 4 times 4x. So the derivative of this with respect to x is going to be z times e to the xc. Okay, everybody see how to do that? Okay, likewise, if I differentiate with respect to y down here, okay, this first term, oh geez, the first term is got the y up in the exponent, and the z is the coefficient. Okay, so if I differentiate that first term with respect to y, I get an 8x. Okay, and then I do the same thing that I did before. I have to bring down the z, e to the yz. Okay, so please remember how to differentiate exponentials. If I differentiate the second one with respect to y, and again, I'm just trying to get you to see the original function up here, and it's not helping. Okay, the only y in the second term is with the 10. Okay, so if I differentiate y in the second term, I get a 10 times 1. And then the e to the xz is a part of the coefficient. Okay, is everybody comfortable with this much? Okay, if I differentiate with respect to z, you can see z is only up in the exponents, right? So if I differentiate with respect to z, here's what I'm going to get. Okay, the 8x in the first term is part of the coefficient. Z is now my variable I'm differentiating with respect to, so y is like the coefficient up there in the exponent. So that's going to give me y e to the yz. Okay, and then doing it for the second term, the 10y is part of the coefficient. Okay, and then if I differentiate that e to the xz with respect to z, I'm going to get x times e to the xc. Okay, everybody all right with it? Okay, if more gives you a problem because your variables are out of order and you got this correct, in other words, show me this in your work, I don't care what order your variables are in, I will give you the points. Okay, the thing you're going to have to be aware of when you take a second derivative, say with respect, let's pick one that's going to be weird. Okay. Second derivative with respect to x here is easy. The first term doesn't give me anything. The second term is going to accumulate another z here. So this will be z squared. Okay. So this will be 0 from the first term, 10yz times z e to the xz, which is 10yz squared e to the xz. Okay. This one is the gnarly one when you take this derivative again, okay, because you wind up having to do, I'm trying to think of what you have to do again. Nope, you're just accumulating another y and another x, so that's not terribly hard. Okay, so f sub y, if I want to take the derivative of this again, the second term has no y's in it. The first term is going to give me another z. Because I'm differentiating with respect to y. So this gives me 8xz squared e to the y z. And here, if I'm differentiating with respect to z again, this is just going to accumulate another y here and another x here. Okay, everybody understand that? Okay, so this was kind of heavy lifting with exponential derivatives. So okay with exponential derivatives. Everybody good with that? Yeah? Everybody good with it? Because again, we didn't spend a lot of time on these, but again, remember how it works. You basically are multiplying e to whatever by the derivative of its exponent. That's what you're doing. Okay? All righty, so I'm going to stop sharing and come back to the main screen. I believe we've gone over every problem on this review that you wanted to see. So let me ask, any other questions? Anybody have anything that's still bugging you? Anything you want to ask about?